Hello, my name is Michelle Moyer. I'm a PhD student at the University of Maryland, Baltimore County, and today I'll be sharing with you my work on female and male song in Orchard Orioles. So first of all, why do we study female song? There's this pretty traditional definition of birdsong by Catchpole and Slater, which defines songs as long, complex vocalizations produced by males in the breeding season. And this was the classic assumption that birdsong was primarily a male trait used for attracting mates and territory defense, and that a female sang it was rare or a vestigial trait not completely lost. Part of the reason that this assumption was so widely held is due to who was studying song. It was mostly men in North America and Europe, and once researchers in the tropics and more diverse researchers began to study song, we've actually found that female song is a lot more widespread than initially thought. In fact, there was this groundbreaking study from Karen Odom, a former lab member, which showed that female song is most likely the ancestral trait, and that 71% of the birds that they investigated had female song. So it's important to understand song as a whole, to not only investigate it in males, but also females, and not only to investigate it in tropical species, but also temperate species. This is my focal species, the Orchard Oriole. They are a migratory temperate breeding blackbird, which can be found across the eastern U.S. and into Canada. You can find them right now in Maryland. They arrived here at the end of April, and they'll stay until August or September before returning to their wintering grounds. Males and females have dimorphic plumage, so they look different. There's a male there on the left and a female on the right. And there have been several mentions of female song in this species, but these mentions are mostly brief and anecdotal, and this would be the first detailed analysis of female song in the Orchard Oriole. Our lab has actually been studying the species for over 5 years, but it wasn't until our work on female song in other species prompted us to look more closely that we actually observed female song in the Orchard Oriole. And so we wanted to do a very intentional and detailed analysis of how female song may function and how often it is produced in this species. So that brings me to my two research questions. We know that females sing, but we don't know how often they sing, and so we wanted to see if males and females are singing at similar rates. We also wanted to investigate if females and males are singing acoustically similar songs or not, or if males sing something completely different than the songs females produce. So we recorded males and females across Maryland during their breeding season, May to June, and recorded them for at least 5 minutes and up to 10 minutes, and determined how many songs they sang during that period as their song rate in songs per minute. We then analyzed 3 songs from each bird in Raven Pro and performed detailed acoustic analysis of 7 different song characteristics to determine if males and females are singing acoustically similar songs. Here are the results of that first question, song rate. On the right is male song and on the left is female song. The y-axis is showing song rate, songs per minute, and the x-axis is showing date. And the reason that we are showing date here is because we were curious to see if there would be any effect of time on the song rate of either sex throughout the breeding season. For example, if the birds stop singing once incubation begins, or song rate begins to dip as the breeding season progresses. But we really didn't see any significant effect of time on the song rate of either sex. However, there is obviously a clear difference here. Males sing a lot more frequently than females do. On average, males sang about 2.35 songs per minute, and females sang about 0.13 songs per minute, and this is a significant difference. However, females still sing a lot more than we initially thought, and they sing well into the breeding season. Of all the females that we observed, 59% of them produced at least one song, which suggests it's not just a behavior performed by a few individuals. Here's some examples of what male and female songs actually look like. As you can see just off the bat, male songs are much longer than female songs, on average about 2.21 seconds compared to the female length of 0.95 seconds. Here's an example of what a male song sounds like. And here's an example of a female song. So this is just one of the 7 acoustic variables that we investigated that males and females differed significantly in. However, males and females did not differ for all of the variables we investigated. We looked at minimum frequency, maximum frequency, full song duration, percent pause or the amount of silence in a song, inflection points or when the frequency shifts from increasing to decreasing, syllable duration, and syllable rate. Of these 7 variables, 2 of them were significantly different between males and females, maximum frequency and full song duration, as I showed on the previous slide. However, we then ran a 2 one-sided test, or an equivalence test, and found that the 5 remaining variables were actually statistically equivalent between males and females. So the majority of the variables we investigated shows that males and females sing acoustically similar songs. This study really highlights the need to re-examine well-studied species. We weren't aware that female orchard orioles sang until we had been studying them for more than 5 years, and now we have seen not only do they sing, but they sing quite frequently, and their songs are statistically equivalent to male songs. So now we want to investigate the context of when females are singing so that we can begin to develop hypotheses about potential functions that female song may have in this species. We are currently performing playback experiments across Maryland, where we are playing male and female song to pairs and observing their behavior to determine if they have any different response to the songs of either sex. I also plan to study female song in a closely related tropical oriole, the Bahama Oriole, to determine if female song in the tropics may differ compared to female song in a temperate species. Thank you so much for listening, and I look forward to taking any of your questions.